Hey everyone, welcome. Getting ready for an exam? If balancing chemical equations feels like this big, frustrating puzzle, you're in the right place. Seriously, don't worry. In just the next few minutes, we are going to make it all click.
Okay, so let's get right to it. Why do we even have to balance these things? I mean, what's the big deal if we just leave them as they are?
Well, the answer is actually based on a super important rule of the universe. But let's forget the fancy science for a sec and think about a sandwich, right? If you take 2 slices of bread and 1 slice of cheese to make a sandwich, what do you get out? A sandwich with 2 slices of bread and 1 slice of cheese. Things don't just magically appear or disappear. And guess what? Chemistry works the exact same way.
And that simple idea brings us to the golden rule of chemistry. Seriously, this is the one thing you absolutely have to know, not just for your exam, but for pretty much all of chemistry.
It's called the law of conservation of mass. Now, I know that sounds super formal, but all it really means is that when a chemical reaction happens, atoms don't just pop into existence out of nowhere, and they don't disappear into thin air. Nope, they just shuffle around and rearrange themselves to make new stuff. So, what's the bottom line here? To follow this law, the number of atoms for every single element has to be exactly the same on both sides of the equation. That's it. That simple act of counting and making sure everything matches up, well, that's what balancing is all about.
All right, so before we can actually start balancing, we got to make sure we know how to read one of these things. Let's do a super quick breakdown of what a chemical equation is really telling us.
Think of it like a story. On the left side, you've got your reactants. These are the starting ingredients, right? The arrow in the middle means a reaction happens. And then on the right side, you've got your products. That's the new stuff you end up with.
It's really simple to remember. Reactants are on the left-hand side, we'll call that the LHS, and the products are on the right-hand side, the RHS. So our entire mission is to make sure the number of atoms on the LHS is perfectly equal to the number of atoms on the RHS.
Okay, time for the main event. Let's talk about how we actually do this using something called the hit and trial method. Now, I know hit and trial sounds a bit like random guessing, but it's not. It's actually a really logical way of making small changes until the whole puzzle just clicks into place.
We're going to walk through this classic example right here, iron reacting with water, or steam, to make iron oxide and hydrogen gas. As it is right now, this is what we call a skeletal equation. It's basically the bare bones. It's not balanced yet.
So step 1 is always to just count what you've got. Let's take a quick inventory. On the left side, we have 1 iron atom, 2 hydrogens, and 1 oxygen. But look at the right side. We've got 3 irons, 2 hydrogens, and 4 oxygens. Yeah, that's not balanced at all. So our job is to fix it.
All right, here's the game plan. A really good pro tip is to start with the messiest, most complicated-looking thing in the equation. In our case, that's the Fe3O4. So let's tackle the oxygen in that first. We have 4 oxygens on the right, so we need 4 on the left. How do we do that? Easy. We just put a big 4 in front of the H2O. Boom, oxygens are balanced. But wait, that changed our hydrogen count. Now we have 4 times 2. That's 8 hydrogens on the left. No problem. To match that, we'll just put a big 4 in front of the H2 on the right. Almost there. Last step, let's balance the iron. We've got 3 irons on the right, so, you guessed it, we just put a 3 in front of the Fe on the left.
And there we have it, our final, beautiful, balanced equation. 3Fe plus 4H2O gives us Fe3O4 plus 4H2. Let's do a final count just to be sure. 3 irons on both sides? Check. 8 hydrogens on both sides? Check. And 4 oxygens on both sides? Perfect. See? It's just like solving a little puzzle, one piece at a time.
Okay, so now you know the steps, but let's talk about the number 1 most common mistake that students make. Seriously, if you can avoid this one trap, you'll be ahead of the game. This is absolutely the most important rule, so listen up. You can only change the big numbers that go in front of a chemical formula. We call those coefficients. They tell you how many molecules you have. What you can never, ever do is change the little numbers at the bottom, the subscripts. Why? Because if you change the subscript, you're changing what the substance is. H2O is water. If you change it to H2O2, that's hydrogen peroxide. You can't change the recipe, you can only change how many batches you're making.
All right, you're doing great. Let's build up that confidence with some quick practice. First one. Sodium plus water reacts to form sodium hydroxide plus hydrogen. Go ahead, pause for a second and see if you can balance it.
Okay, you ready for the answer? The balanced equation is 2Na plus 2H2O gives you 2NaOH plus H2. So the coefficients are 2, 2, 2, and an invisible 1. If you got that, awesome. If not, no worries. Just take a second to count the atoms on each side. It works out perfectly.
Let's do one more. This one's a little more straightforward. How would you balance hydrogen gas reacting with chlorine gas to make hydrogen chloride? And the solution is just putting a 2 in front of the HCl. See? We start with H2 and Cl2 on the left, so we need 2 of everything on the right. A single 2 in front of the product does the trick. You guys are getting a hang of this.
We're almost at the finish line. There's just one last little detail we can add to our equations to make them even better and more complete for your exam.
These are symbols that tell us the physical state of everything in the reaction. A little S means it's a solid, L means it's a liquid, and G means it's a gas. Oh, and there's one more you'll see a lot. AQ for aqueous. That's just a fancy way of saying it's dissolved in water.
So if we go all the way back to our first iron example, we can add these states in. Now the equation tells us a much better story. Solid iron reacts with water in its gas form, which is steam, right, to produce a solid iron oxide and hydrogen gas. See how much more information that gives us?
So at the end of the day, just remember this. When you balance an equation, you're doing more than just solving a math problem. You're showing one of the most basic rules of the universe. Nothing is created, nothing is destroyed. It's just transformed.
Okay, so you've totally nailed how to balance the atoms, the matter. But here's a thought. Chemical reactions don't just move atoms around, they also involve energy, right? Things heat up, or they cool down. So that leads to a really cool question. How do you balance the energy in a reaction? That's a great topic to think about for next time. Thanks for joining me.